Hello everybody. So what I would like to do today is give you an overview of what is new in OpendTect version 4.6. I'll start my presentation with a few words on our release policy. Then I'll discuss what is new in the OpendTect, that is the open source part itself. And I will demo a few of the highlights. Then a few more slides on what is new in the commercial parts, that is the plugins. And a final slide of where we are going. On the release policy, we strive to make one major release every year, and once this is released we follow up with patch releases in which we are mainly solving bugs and only little new functionality is added. Patch releases are released every third week of every month, and they are recognized by a small letter behind the release number. At some point we will branch off the development release, and once this has stabilized sufficiently we will release that to the audience for testing. This is then a preview of our new technology, and eventually this will become the next major release. Commercial plugins in OpendTect are protected by FlexNet license keys, and these we upgrade every time we do a major release, so that is typically once per year. These FlexNet license keys can be used both to run the then current official release as well as the then current development release. Each release will have some release notes, and we have specific release notes for OpendTect as well as release notes for the various plugins by different vendors like DHB, ArcGLS and Earthworks. You can find these release notes on the OpendTect download page. This is a typical release note. This is the release note that came in when 4.6 was released in September a few months ago. And it's just a bullet list of what is new and what has been fixed. Now the highlights in 4.6 are the following. We have completely re-engineered our 2D viewers and also launched a new pre-stack viewer. It's now possible to compute angle stacks. We have made the rock physics library much more easy to access. This was a little bit hidden in 4.4. Also we improved the generation of synthetics by implementing Backus averaging. Well-log tools have been improved. You can now do various filters and apply these to improve your well-logs. And we have improved the attribute engine by now supporting cross evaluation of chained attributes. And I would like to demo a few of these things. Let me start by the pre-stack viewer. Well, I think most of you who have worked with pre-stack data know that we have this type of pre-stack viewer already in OpendTect, and this is in the 3D scene. But now once you right click on one of these pre-stack gathers, you can pop up a new flat viewer, and that flat viewer will then look something like this. So here we are looking at just a number of selected pre-stack gathers along this particular inline, and I can now overlay the angles that are computed in this particular case, and that's a little bit explanation I have to do here. In OpendTect we have a simple ray tracer that we release in the open source domain, and we also have an advanced ray tracer, but that is only released in the commercial plugins by DHB. So if you're purely working in OpendTect, then this is what you will get if you calculate angle stacks. So it's nicely colored in the background now from 0 to 60 degrees. I'll show you the difference with the advanced ray tracer. Just toggling it on and off. And now I'm switching to the advanced ray tracer. And you can see there is slightly more detail here in how the angles are calculated. It's more correct. Okay, that is just pre-stack viewing. Let me now switch to this OpendTect scene. This is the normal 3D scene. Everyone will recognize the F3 data by now. And I'm displaying now a texture attribute on this seismic. So we have both seismic and texture displayed. Any seismic display in OpendTect, you can now pop up and display in a 2D viewer. And you can either display it as a wiggle display or as a variable density display. Now you can either do that from here, from the menu, or you can do it directly by using these icons. So here I'm displaying the seismic in wiggle display. I'm going to display the texture display as variable density. This is the new 2D viewer. Here I can zoom in by just rolling my mouse button. And if I'm in the view mode, I can pan through the data by just left mouse clicking and sliding, panning. So that is the new 2D viewer. Another feature I'd like to show is this one. We have here an amplitude anomaly in 3D, and I've just created the body from that amplitude anomaly. And so here we have it. It's now possible to compute from this body automatically or directly the volume from any body. So right click on the body, either in the menu or on the body itself. You get a new menu. You have to specify some kind of average velocity, and then it will automatically calculate how many cubic meters this body represents. So nice little add-on, new feature. And the next thing I'd like to show is the rock physics library, which has been given a more prominent place. It's now available here from the this icon directly in the main window, but you can also pop it up from analysis, wells, rock physics. It pops up with a message here on what to do. Basically this is the manage well database, and from here I can create new well logs using our rock physics library. So here you can use any mathematical function, and there are many mathematical functions already pre-cooked. For example, if I want to calculate density from sonic using the Gardner's equation, then this is the formula. But I can choose from any property that I'm interested in. For example, I want to use impedance, and I'm interested in extended elastic impedance. I get a huge formula, and there are various places where you get also help on default settings and so on. So that is the rock physics library. This manage well database or manage well system has also a few other updates, like time depth models. We now calculate automatically also the TVD subsurface and the free interval velocities. That can then also be exported. In markers, we can select a number of markers, right click on the marker, and you can remove the markers that you're not interested in. And under well log tools, this button here, we can select a number of wells and get a display. It looks like this. So we're displaying here a number of porosity logs, and I have a number of tools here to remove spikes, for instance. The red curve is the new edited log. I can save that as porosity underscore whatever I like, edit it, or whatever extension I give it. And this tool has also filtering possibilities, a low pass filter or a band pass. There are smoothing options here. So kind of running average and clipping possibilities. Okay, that was the rock physics and block tools that I wanted to show, and then the last thing I'd like to show is the possibility to cross-evaluate attributes. So we're going to look at this small portion of a seismic data set, an inline here with a nice amplitude anomaly, and we're going to do some attribute analysis in here. So I've created a small attribute set like this, and I trust that everybody knows how to do this, but this has been available since a long time in the attribute engine. So I click this particular icon here. We are now calculating this particular attribute on the current active element. So what you're looking at here is a texture attribute displayed on the seismic data. And also this one I trust that everybody is familiar with. That is really one of the strong points of OpendTect, evaluating attributes interactively, testing their parameters. I'm going to create energy in different time gates, and I'm going to evaluate the effect of varying the time gate from 0, 0, then with 4 steps increase on either side, all the way to 40, 40. And by using this slider I can see how that affects my attribute response. But what you could not do in the previous version is to evaluate the parameters that are going into a chained attribute. For example, I have here frequency washout ratio, which is created from 4 other attributes, all calculated on the fly. The frequency washout ratio is an interesting attribute that captures the frequency decay which you typically see below hydrocarbon anomalies, and it's defined as the energy of the low frequency content of the seismic divided by the high energy part of the seismic. So what we have to do this is we first have to calculate the low pass of the seismic. So we just apply a band pass filter to the seismic. This is the low pass part of the seismic. And we do the same for the high frequency part. So now we have applied a high pass filter. Then we calculate the energy of the low pass. Again, this is all done on the fly. And we do the same, the energy of the high pass. And then finally we are going to do the frequency washout, which is the division of energy low pass by energy high pass. And now we're going to evaluate how this energy changes when I change my time gate of the energy low pass and high pass. So what I'm going to do here is I'm starting with an energy time gate of minus 30, and I'm increasing the time gate with 10 milliseconds on either side. I'm going to do that 10 times. Calculating the response and sliding through it again. So this type of cross-evaluation of chained attributes is now possible. And once you have done this, then of course it makes sense to display this in a slightly different way. Here we have the frequency washout zone just below the amplitude, and this is the amplitude energy, high energy caused by hydrocarbons, frequency washed out below it, typical case of yes, these are hydrocarbons. Okay, that was what I wanted to demo. This has been new in OpendTect itself. Let's now continue back and have a few slides on what is new in the various plugins. This to me is one of the real highlights. Every now and then you release something where you think, yes, this will be standard technology. I predict that this will be copied left and right by everybody who is following OpendTect. It's a dip steer tracker. What does a dip steer tracker do? It is infilling sparsely interpreted 3D seismic horizons. So typically when we interpret a horizon, we interpret a number of inlines and crosslines in a sparse grid, and then we just create a complete horizon by applying some kind of mathematical gridding algorithm to infill the horizon. Typically this is done with inverse distance or maybe some kind of a triangulation. Now what we do here with dip steered gridding is that we are using the data, the dip calculated from the seismic, to do this infilling. And we're still honoring all the interpretation points accurately. So it is both giving a more accurate result as well as that it is faster, because I have to use less number of interpreted lines to get an equal good result. This is the horizon after dip steered gridding. And if we look in detail at, say, one line through this volume, and we compare this with a conventional gridding, then we see how much better we are doing. The green line has been following the data by using the dip steered gridder, and the red line is interpolated using a mathematical type of gridding algorithm, so it doesn't know anything about the data. Both are honoring the interpretation points, but the dip steered gridder is much more accurate as it follows the data much more accurately. Now what is new in the HorizonCube? A lot of things. We can now do 2D editing. We have an improved 3D editor. We can calculate more attributes from the HorizonCube itself. We have upgraded the HorizonCube slider. That is the slider where you can, in the structural domain, display any horizons, both a top and a base. You can then automatically calculate isopac thicknesses and from there create bodies. This slider can now also be used to display any type of attribute. We can also now create HorizonCubes in 3D bodies, and we have seen various improvements in terms of fault trimming and adding iterations to 2D HorizonCubes. In the SIS module, the sequence stratigraphy interpretation module, we can now do Wheeler transforms for random lines. We have added various depositional models like channel stages and stratal packages. We added absolute geologic time to the Wheeler scene, and we also added and improved the sequence strat interpretation window itself by adding relative geologic time and statistical curves. For example, it's now possible to calculate the thickness from interpreted systems tracts and display these as an additional curve which says something about depositional ratios. Another highlight, of course, in 4.6 release was the release of Syntroc. We have spent another webinar on this, but Syntroc is our tool for both forward modeling and inversion. There are two forward modeling modules in Syntroc. That is a well profile module, which is used for quick sensitivity analysis, and there is a stochastic module which allows you to generate thousands of stochastically generated pseudo wells. From these you generate synthetic seismograms, and these you then cross-match against the seismic to get rock property probability volumes in an inversion approach that we call the hit cube. Now what is coming next, and this is already my last slide. The next release will be called OpendTect 5. It's a major release, super major actually, because it will be the first release in which we have a complete new underlying graphics library. We had to get rid of Coin. Coin is the library used in OpendTect so far, but Coin is not developed further. So OpenSceneGraph is the new graphics library of choice, and We will have new interactions and new functionalities, but basically OpenScene Graph is primarily chosen because it is making OpenTect ready for the future. We'll also be switching to Qt5, which will allow us to get better interaction with finger touch screens and pen devices. And we have already developed a MATLAB connection. This was a project sponsored by BG, and this allowed us to use MATLAB code in OpenTect and to import MATLAB generated data and visualize it in OpenTect. It's a project that has been finished already. We will be releasing it with 5.0 in the open source domain in OpenTect itself. Also at the moment we are undergoing a major revision of our documentation. The user doc has grown into a document of 600 pages plus. It's very large, and it's also very difficult to find information if you not know where to find it. So the new system will have much better search facilities. It's much better indexed than the old system. In general, what we strive to get in OpenTect 5 is improved user friendliness and the highest quality we can achieve. So stability is very high on our agenda. Obviously, we will also continue developing the plugins further. Syntrock, HorizonCube, Sys, and many of the others will get a boost with new functionalities. And our target release date is June 2014. And that is my last slide. Venice, can you take over again? And
yeah, sure. Thank you very much, Paul. And now it is a time for the attendees. Please, if you have any question regarding the presentation, please feel free to write your question or to raise your hand. Now we have one. Okay, Stanley. Yes, Stanley, you can go ahead and say your question.
Yeah, Paul, a simple question. For OpenTect 5, when will that be released to consortium members?
Yeah, it's OpenTect 5, which will be released to the bigger audience in June 2014. But we are preparing indeed snapshots of what we have done in the Sys consortium and release this to our consortium members. And the next release should be somewhere early next year.
Okay.
Okay, good. Any other questions? Yeah, I have here a question from Doreen Blanca. Can we know more about the advantage of OSG in OpenTect?
Yeah, I think that is better to be answered by Christopher, who is really into these type of things.
Okay, Christopher, I send you a question.
Christopher Engdahl here. Yes, the advantages, well, in one way for the end user of OpenTect, what underlying library we have in doing things in OpenTect gives the ability to create more advanced visualization. In 2001, when we started to create the 3D visualization in OpenTect, we went for a system called Coin, and that was, I think at that point, was a good choice. The problem is that the company that maintained Coin went out of business, and therefore we had to switch. Our choice now, well, and the consequence of that they went out of business is that it's no longer updated. All the new functionalities that are sitting with modern graphical hardware is not available as we wish in OpenTect at this time, and therefore the biggest benefit for the end user that we're switching to OpenScene Graph is that we have a system that is much more advanced and in creating more advanced displays. We have examples of this is the volume rendering, and various other things that we have prepared for. All of this is not going to come in OpenDTEX 5.0, but in subsequent releases after that. But it's a platform that we can build advanced features on, and that we did not have previously. Did that answer your question?
Okay. Yeah, he's saying thank you. All right. So, yeah, Stanley again. Yeah, go ahead.
I just want to support the audience. First of all, thanks, Paul, for the opportunity to present some of the functionalities in 4.6. But I just wanted to ask a question about connectivity. I know that we used to have a connectivity with GeoFrame 4.4, and then I believe ArcCLS was responsible for that plugin. But what about Petrel? Since that has become a common platform now, and a lot of us have our databases on Petrel, and it's easier if we can just do a simple data transfer across. So maybe it exists, but I don't know. So I'm asking the question: do you have a connectivity to Petrel?
There are different commercial plugins available for connecting directly to Petrel. There is a tool that is called the Petrel Connector, which is available from the Ocean Store, and this allows you to copy 3D seismic and horizons to and from Petrel into OpenDTECT and vice versa. And a second possibility is what is called the Geodata Sync. This is a new tool that is under development by ArcCLS. It has recently been released. The Geodata Sync module is launched from within Petrel. It then launches OpenDTECT, and it allows you to work in Petrel natively with data files from OpenDTECT. So there's no copying involved. You directly work on the OpenDTECT data store. At the moment, this is one directional. That means you start it up from Petrel. And we are talking at the moment with ArcCLS in making this bidirectional, so that it also would be possible to work from within OpenDTECT and access data in Petrel natively without any data copying. But that is something that is under development, or at least we are discussing the possibilities to develop this. So to summarize, yes, there are connections to Petrel. The Petrel connector is available right now from the Ocean Store. The Geodata Sync is available for accessing data without copying, and this one is available from ArcCLS at the moment.
Okay, thank you.
Okay, thanks. Okay, here we have another question. I'll give it to Christopher Tingdahl.
Yes, I'm reading out the questions to everyone. Basically, this is Mr. Singh. That is, he writes that he's hoping that the MATLAB will provide spreadsheet connectivity also. I have I do not fully understand the question, but I can elaborate a little bit on what the MATLAB plugin does. The MATLAB plugin will allow some of the functionality of OpenDTECT to be used in MATLAB. So if you write MATLAB code, you can read in volumes from within the OpenDTECT. Also, it will provide the ability to use MATLAB code as a part of the calculations in OpenDTECT, so that for, say you have an attribute that you have created in MATLAB code, and you can then use the plugin of, or the MATLAB plugin to OpenDTECT to access that code, that MATLAB code. So the calculation as such is run directly in MATLAB, and the results are coming seamlessly into OpenDTECT again. So it's a data, it transfers data on the fly back and forth. That is, as far as I understand, the status of the MATLAB plugin as we speak right now. well, the problem with writing a Muffler plugin as such is you have to decide what data format that will be available back and forth. And therefore, we have chosen a subset of things where we think the interest is the largest. But if anyone has a suggestion for further functionality there or things that they wish to do, well, the appropriate place to address that is to contact our support, and that your request will be forwarded to the appropriate person. I hope that answers your question.
Yeah, good. Okay. Yeah, he said yes, thank you. So I don't see any more questions, so thank you everyone. And if you are just interested to listen to this again, you will receive a link with the video of the recording of this presentation. It will be for, it will come to you in the email for around a week from today at the most. And please, feel free, if you have any question regarding this presentation later, just you can email us at webinar@dgbes.com. And I wish every one of you a Happy New Year, and we will meet you again next year. Please join us again. Thanks everyone, thanks Paul, and thanks Chris, and thanks for all the attendees.